Okay, pre-algebra guys, we are jumping into 12.2 pairs of angles. All right, so this is going to be vocab heavy in this section. I highly suggest that you follow along in your book. If you'd like to write everything down, you can. I know it's really difficult with me not showing you exactly how to have it all in your notebook, and so you can use your textbook on the assessment. So anyway, hang in there with me, but follow along in your textbook. There's just going to be a lot of vocab today. A lot of it is something that you've probably had before, but still, it's a lot to cover. Okay, so angles. We talked about angles yesterday. They're like two rays, essentially, that go out in different directions. They have a vertex, the point at where they come together. Generally, they will have 3 points labeling it, and we call them angle A, B, C, and we name it with its vertex in the center. This angle has 2 names. He could be called angle CBA or angle ABC, and they're both exactly right. One is not better than another. They just simply go in a different direction. So with geometry, what we're going to find is that direction matters a lot. So for angle CBA, we start at C and we go to B, and then we come over here to A, and that's our angle. If we were to come at angle ABC, we'd start at A, we come down to B, and come over to C. Now, do you see that's the exact same angle, right? Well, what if I said, hey, I want you to find angle BCA? Well, is that the same angle here? Angle B, start at B, come over to C, go to A. Wait a minute. This here is not the angle I want. I want this section in here to be my angle. So that is why it's really important to make sure that you put your vertex in the middle of your naming. Okay? All right. That is an angle. If we have 2 angles that add up to 90 degrees, they're called complementary angles. 2 angles whose measures add up to sorry, I can't write and talk at the same time. Add up to 90 degrees. Okay? So if you see here that we have 35 degrees, if we were to move it over here and add it to 55 degrees, would we have a right angle? Well, let's see. 55 plus 35 gives me 90. So yes, these are complementary angles. Do they have to be adjacent or touching like this? No, they certainly do not. And I can actually undo this to show you. They need to be separate. They're just 2 different angles that happen to add up to 90 degrees. This guy could be way over somewhere else. Adjacent angles are angles who share a side like this. And so they can also be complementary, but they don't have to touch like that. Okay? All right, complementary angles. Now, well, I'll show you this in a minute. Okay, supplementary angles add up to, do you remember? 180. And it's really important to know that there are 2 angles. I didn't say that before. 2 angles whose sums add up to 180 degrees. Okay? The same with complementary angle. You have to have 2 angles that add up to 90 degrees. You can't have 3 and call them complementary. It's only when you have 2 angles. All right. If I were to take 45 and 135, and if I were to put them together, that sure looks like a straight angle, or 180 degrees, half of a circle. So let's see. 45... If I were to add that to 135, yep, I get 180. So these are supplementary angles. And now there's a lot of different combinations. Now you could set this up in a very systematic way, like algebra. If I were trying to say, what is the supplement of 38 degrees? I could say, some supplement plus that 38, right? I've got some angle here plus another angle, and I want them together to add up to 180. This is a missing amount, and when I put it together, I want it with 180. I want it with something else to add it to 180, right? So you could subtract an s from, I'm sorry, not an s, you would want to subtract 38 from both sides, and you would find that s is equal to 142 degrees. Therefore, 142 and 38 are supplementary. You could add them back up and get to 180. Now, I know that sounds really obvious, and when you look at it, you say, oh, I know exactly how to find that. You just subtract, you do it in your head. You would never write this section out. No, you won't write this section out at this stage, but in the future, if we're not comfortable with at least seeing it that way, it's going to be more difficult when a problem in geometry becomes more complex. All right. Oh, we actually just did that. Okay, let's take a look at this protractor. Now, we are not going to be in class. Most of you probably don't have a protractor at home, so we are just going to kind of look at this a little bit here. We have a straight angle. What is the straight angle? Yeah, it's this one right here. Now remember, the vertex or the middle has to be in the center. So we would have to call this angle RSV, where S is in the middle. Or you could say angle VSR. That's a straight angle. It adds up to 180 degrees. So we start here at my 0, and I travel around here, and I read that it's 180 degrees. Or you could use the inner markings of numbers and travel around here and find that there are 180 degrees. Okay, let's get clear off this board a little bit. I want to know what are the supplements and the complements, if they're, some of them may not be possible. What are the, if you had an angle that's more than 90 degrees, you can't add something to it and have 90. That's what I mean by something not being possible. But let's find the supplement and the complement for any angles who might have either one of those, okay? So I'm going to call this the complement and call this the supplement. Now, they all will have a supplement because none of them, except for that straight angle, are already 180 or more. Now, what would be important information to know before we even get started? How much more do I add to get to 90? Well, I don't know where I'm starting at. So let's use what we know about angles and follow. These are literally directions like your Google Maps would tell you. Start at U, come through S, and then go to V. So you can write right on an angle in your book, or if you write in your book or on a piece of paper, start at U, come down here to S, that's your vertex, and come out here to V. This would be my angle. And so if my angle is here, I can't start at 180 and say, hey, this is a 115 degrees. Well, that's not true. This is more than 90. There's no way that you could have more than 90 and it would be an acute angle. Okay, so just check that. You can think about it logically. It's important to know that the straight line of your angle, if it's on this side of the protractor, you've got to start where it says 0, and then we're going to use the inner markings. If the straight line of our angle is over here, we don't want to start at 180 for the inner markings. We want to start where it says 0. So find the 0 and then follow those markings. Does that make sense? Okay, so we're going to find our horizontal line here, start at 0, and then follow the inner markings, and this is going to be 75 degrees. So I'm just going to kind of write this off to the side. This is going to be 75 degrees. Okay, sorry, I had a bad cut there. You might see that I wrote 75. Anybody point that out? It's actually 65. I can't read off of that and be distracted at the same time. Sorry. Okay, sorry if you can hear my kids too in the background. But you get what you get. Here we go. This is COVID-19 math, okay? All right, so we're reading up here. Let's try this again. We can count. Actually, maybe I need to be doing this too. 10, 20, 30, 40, 50, 60. Not quite 70. It's 5 less than 70. It should have been 65. Okay, so what is the complement? How much do I need to add to this to get to 90 degrees? And I told you I was going to give you a little hint here earlier, and I forgot. So a complement and a supplement are the two. But if you look here, this C almost looks like part of a 90, and the S almost looks like part of an 8, so 180. That's just a quick way to be able to remember which is which. So complement is 90, supplement is 180. I don't know if you've ever seen that before, but I honestly still think about it that way sometimes to remember. Okay, so how much do I have to add to get to 90 degrees? Try to make that line straight again. There we go. All right, well, you could either do the math. You could take 90 minus 65, or you can just look on here and say, okay, how much further do I need to go? I need this little section. That's 25 more degrees. So the answer for the complement to angle USV is, get my marker out, 25. Okay, now what's the supplement? So this angle here is the complement. The supplement would be an angle that comes all the way here and turns this into 180. So this angle here will be my supplement. I need to know, okay, if I have at 65 plus, how much is going to equal 180? So you could do the math here, or you could read right off the protractor, okay? But either way, you'll get 115 degrees for the supplement. Okay, let's look at the next one. Angle RST. So let's follow the roadmap. These are your directions. You are doing Google Maps, so you have to follow R over to S. That's your vertex, and then come up to angle T. Okay, so now I want you to think. Are we using the inner number line or the outer number line? Well, here's our horizontal line, and we want to say we are using the one that starts with a 0, which in this case is the outer number line. So 10, 20, 30, 40. This is a 40-degree angle. So for my complement, how much more do I need to get to 90 degrees? Well, 40 plus what gets you to 90? 40 plus 50 gets you to 90 degrees. And how much would you need to get all the way to 180, this bigger angle? Now you could do the math again. You could take 180 and subtract 40. That's my original. I guess I never wrote that one down over here. We have that this is, oops, a 40-degree angle. Okay, so how much more do I need to get to 180? Well, you need 40. Make that blue or red. Okay, 140 degrees. Okay, RSU. So let's go ahead and draw on here. We're going to say R, follow the road map, S, that's your vertex, come up to U. How much is this angle measurement? RSU. Well, let's count with the outer number line, and we are going to be at 115 degrees. Make that in a color we can see here. Okay, 115 degrees is the number itself. So how much do we need to add to this to get to 90? Can you add to it? No, it's already more than 90, so it does not have a complement. Okay, it just doesn't have a complement. Now, how much to add to get to 180 we can do? How much further do we need to come to get to 180 degrees? Well, it's kind of similar to this guy up here, I suppose. We have 65 degrees. We could count it if we want. 10, 20, 30, 40, 50, 60, and a little bit more. Okay, so 65 degrees is the supplement to RSU, which is 115 degrees. Okay, let's keep going. We've got a lot of vocab to cover. Okay, so if we had two lines that are parallel, we are going to note them in a couple different ways. Who remembers the definition of parallel? Actually, I'm going to come over here first. The definition of parallel are two lines who never intersect. They also have to be in the same plane. Okay, in the same plane, means on the same piece of paper in a way, and never intersect. They're the same distance apart, no matter how far you go. We will often note it with a tiny little extra arrow on either one of them. So if we had another set of parallel lines, we might have two markings on it, okay? And those show that it's parallel. Now, when you have two parallel lines, you can also have what we call a transversal. So a transversal will mark by T. So let's say that R and S are parallel lines. They're never going to intersect. we have this line that cuts through both of them, and then there's a lot of things that we can know about them. If these two lines are parallel and we cut them by a transversal T, we can name this a transversal. Okay, if we cut it through on there, it goes through both, then we can identify a bunch of different things. The first thing we're going to identify is that we have alternate interior angles. And these are going to be equal to each other. So alternate interior angles are going to be on the inside. So here's the inside section. Here, if you're in this yellow section here, you're on the inside. Okay, if you were out here where it's green, this would be an exterior, and we'll do that in a little while. Okay, so alternate means to go back and forth. If we alternate, if we were to go alternate between a boy and a girl playing a game that we were doing in class, I would go between and back and forth, right? I'd say, okay, I'm going to choose a guy this time, then I'm going to choose a girl, then I'm going to choose a guy. So we're going to start on this side. Oh, I need to go back to my other pen. Start on this side of the, get this color, sorry guys. Okay, start on this side of the transversal. So 3 and 6. Measure of angle 3, well, let's say angle 3 and angle 6 are alternate interior angles. Okay? Could you find another set of interior angles? Yeah, we've got the other side. They both have to be in the yellow section because they're interior, but angle 4 and angle 5 are also interior angles. And what we know, based on some rule that we won't get into until geometry, is that their measures are equal. So we could say that the measure of angle 3 is equal to the measure of angle 6. And we could say that the measure of angle 4 is equal to the measure of angle 5. Now, I can't just say angle 3 equals angle 6, because that's not true. They're not the exact same thing. But I can say that their measures, or the degrees, are the same. Okay? Now, I know that's a little bit confusing, but what you'll need to be able to identify is which ones are alternate interior angles. All right, now what if we were to say alternate exterior angles? We already did this a little bit. We said, okay, here's the inside, right? And then we said, here is the outside, the exterior, right? If you have exterior paint, you would use it on the outside of your house. Interior paint's for the inside. Okay, so alternate, it's going to be the same thing as before. Oh, I still have to go back to my other pen. I have to be on the left side of the transversal, and then I'm going to come, here's the transversal, and come on the other side. So angle 1 and angle 8 are alternate exterior angles. The other set would be 2 and 7. Angle 2 and angle 7 are alternate interior angles. And we know now that their measures are going to be equal. Now, this is only true if these two lines are parallel. This is a lot of information. So I just want you to be exposed to it. What you're going to need to be able to do is identify alternate interior, alternate exterior. Okay? So the measure of angle 1 is then going to be equal to the measure of angle 8, and the measure of angle 2 is going to be equal to the measure of angle 7, and I'm taking it straight from here. I'm just kind of rewriting it to say the measure of, and then setting them equal to. All right. Corresponding angles. Corresponding angles are the angles that go together, go with each other. Okay, so let's imagine that this here is an intersection. So you're driving in your car, and you're coming down the road. Here's your car. All right, and you're traveling down the road, and you're saying, I'm going to go this way, and I'm coming to a stoplight. Oh, I think yellow. How did I mess that up? Green's on the bottom. Okay, so here is your stoplight at the intersection. Okay, and you might know that there would be a north section, a northwest section, a northeast section of the intersection, a southeast, and a southwest. Now, I guess it depends on which direction you're going, whether it's to the left or the right, but the cardinal directions will always be the same. So it's basically, if you're traveling down here, you've got an intersection, you've got a corner that you might come to first, it might be over the road, things like that, right? 1, 2, 3, 4. Well, I have another similar intersection here, okay? So if I'm coming to another stoplight from the same direction, I can say, hey, there are 2 intersections that are on the northwest corner. Now, you don't have to really remember all of that for directions, but do you see how this is in the upper left corner? This is also in the upper left corner. That means these are corresponding angles. And their measures are equal as long as my lines that are cut by the same transversal are parallel. So I could say that the measure of angle 1 is equal to the measure of angle 5. I could also say the measure of just angle 1 and angle 5 are corresponding angles. All right, I could also say, so angle 2 is in the upper right-hand corner. Well, 6 is also in the upper right-hand corner. So angle 2 and angle 6 are also corresponding angles, or their measures are equal. It's looking a little sloppy. Sorry, guys. Let's see. Measure of angle 2 is equal to the measure of angle 6. All right, 2 more we can do here. All right, the lower left-hand corner from both different intersections are corresponding. So angle 3 and angle 7 are corresponding angles. Therefore, they're what? Their measures are equal. All right, and last but not least, we have a lower right-hand corner of the intersection. These are corresponding angles, so angle 4 and angle 8 are corresponding angles, which means that their measures are also equal. Okay, we just covered a ton of information. So let's back up here a little bit. Alternate interior angles are in the inside. This is all when you have parallel lines, you have them cut by a line, and you have 2 intersections that are created. You've got an inside that's yellow, and you can have alternate interior angles. In this case, 3 and 6 are alternate interior angles. 4 and 5 are alternate interior angles. They're on the inside, and they're on opposite sides. So this guy's on the left. Oh, here we go. This guy's on the left of my transversal. And if I cross this line, this guy's on the other side. Okay, alternate exterior angles, same idea. Opposite sides of the transversal. Here's your line. One has to be on the left, one has to be on the right. But they have to be in this green external section, the exterior. And their measures are equal. And corresponding angles are also equal, and they are the ones that have these intersections in a way, and you have this upper left corner, upper left corner. Those are your corresponding angles. They're equal in measure. And upper right, etc. Okay, I know that was a lot. Hang in there with me just a tiny bit more. Okay, so let's test your knowledge of all that tons of information that I just spit at you, okay? All right, here is another set of parallel lines. We know that they're parallel because they have these little markings on them. Okay, they appear to continue going on for ever and ever, and they're the same distance apart. This is my transversal line. Both of them are cut by the transversal is what we say. Actually, I should probably make this a different color just so that we can recognize that it is not our parallel line. It's the one that's making all these angle measurements. Okay, so I have angle 1, 2, 3, 4, 5, 6, 7, and 8. Now, there's a ton of things that we can figure out here. Let's list a few. Let's find another angle that is equal. Well, let's back up a little bit. Let's find a pair of alternate interior angles. And I'm going to note it this way. Okay, so alternate interior angles. Think about that for a minute. Interior has to be in this yellow section, and they have to be on opposite sides. So if you said angle, I need to go back to that one. Okay. If you said angle 4 and angle 6, you'd be right. If you said angle 3 and angle 5, you'd be right. What about alternate? Let's see what color here. Alternate exterior angles. Think about that for a second. Okay, they've got to be on the outside of those sections that the parallel lines make, and then on opposite sides of the transversal, or that pink line. Okay, so if you said angles 1, oh no, I keep doing that, sorry guys, got to be able to read this, angle 1 and angle 7, you'd be right. If you also said angle 2 and angle 8, you'd be right. All right, last one are corresponding angles. I'm going to come to this other side so you can see everything okay. All right, corresponding angles. There's a lot of these. Take a minute and think about it. Remember, this is like the same section of the intersection. So we've got two parts here. You're going to have one from that red circle, and you'll also have to have one number from this blue circle here. If you said angle, oops, all right, if you said angle 1 and angle 5, you'd be right. Angle 2 and, let's see if I can write this the right way, and angle 6 are corresponding angles. Angle 3 and angle 7 are corresponding angles, and angle 4 and angle 8 are corresponding angles. There we go. Alrighty. Now, I want you to give me 2 angles whose measures are the same, or who are have a degree measurement. If you were to measure them with a protractor, which ones are the same? Well, I've got a whole list right here, right? You also have a whole list over here and down here. Any of these would be true right now. So I could say that angle 1 is equal to angle 3. That's vertical angles. You haven't learned that yet. I'm sorry. Angle 1 I could say is equal to angle 7 because it's an alternate exterior angle. I could also say that angle 1 is equal to angle 5 because they're corresponding angles. I could say angle 8 is equal to angle 4 because they're corresponding angles. Or I could say angle 8 is equal to angle 2 because they're alternate exterior angles. I could say that angle 3 is equal to angle 5 because they're alternate interior angles. Okay, their measures are equal. I have to be careful to say it the right way. Their measures are equal. All right, well, I'm going to stop us there, and you will need to kind of identify a couple of those things, mostly take a look at complements and supplements, which you have done many, many times in the past. So hopefully that's some quick review for you. And then tomorrow we'll have a video, but tonight is your last homework, so do your best on it. Knock it out of the park, and you will almost be an 8th grader. Good job.